one of the central scientific questions of economics is to study how a massive decentralized or market-based system populated by intelligent optimizing agents would respond to a large shock. And of course, there are many examples of this, but we had a particularly evocative example in February when there was an unprecedented cold snap and there was suddenly peak demand for electricity in Texas and its neighboring states. And this huge peak demand shock coincided with a big supply shock that led to a lot of generators being out of line because, as we read in the news, natural gas wellheads froze as well. So what are we going to do in this project? We're going to, of course, we read about those power outages that this caused. But what we're going to do is we're going to use a massive data set that we obtained from MISO, the Mid-Continent Independent System and Operators, that covers much of the Midwest, along with parts of Texas. A lot of people don't know this, but it does cover parts of Texas. That has very detailed micro-level data, minute by minute, on the what happens in all these generation power plants, and also these demand nodes. And we're going to need the tools of big data analysis, visualization, and modeling tools to first really dig through this data. But then the idea is to model the behavior of these, again, these decentralized, intelligent optimizing agents that populate this transmission grid to see how they responded to these shocks. Another important question is, that we display in this graph is the importance of transmission constraints. Here, this is the map of MISO with this neighboring system on the east of PJM. You see the area that's in the south in red, that's where the prices hit, very extremely high levels, hitting the price caps. While the northern regions, as you can see, they're much more in the blue. Indeed, the purple regions, we had almost negative prices during February 16th. So how can this happen? That's because of transmission constraints that, we don't have enough transmission lines to supply electricity from the north to the south. So one question here is, what is the impact of more transmission investments? How is it going to help stabilize some of these shocks going forward? And our aim is to come up with a simulation model that's faithful to the individual optimizing behavior of the agents that can also utilized to assess the effect of changes in transmission capacity and changes in generation technology, and how this affects system reliability.